All right, let's get it going. So our next speaker is Ewan Hicks, who will be talking about running Hadoop on existing HPC infrastructure, which is interesting because I've actually spent some time on the project doing the other way around, running sort of HPC applications on existing Hadoop infrastructure. But Ewan will be talking about something else completely. So here's Ewan.
I'm Ewan. I'm the big data coordinator for HPC at Ghent University, and I work on a project called Anything on Demand. We call it HOD for short, sometimes HOD. So today I'm going to talk about why we've made it. I'm going to go into a little the shallow end. I'm not going to do any deep dives into the code or anything, but I'll show you a few things like how to maybe use it if you'd like to do that. And show you some use cases. We have some users using this for actual research. And as it's FOSDEM developer meeting, I'm going to talk about a few community things, see if I can get some improvement. Is anyone here using HPC systems? Quite a lot. And is anyone administrating them? Okay. And using and not administrating? All right, so for the HPC administrators, this could be a really useful tool for you guys if you've got a lot of people in your organization that are using HPC stuff, fast, with Romax, Quantum Espresso, blah, blah, blah. But then you get a few users like us who say, I really want to use Hadoop. Why don't you just build a Hadoop cluster? Because, get a new cluster maybe every year or so. Let's go in that direction because everyone's doing that. And so we've made Anything on Demand. The code is on GitHub. You can take a look. We have quite a bit of documentation, which I think is really good. Kenneth helped me with writing that and getting the documentation so even undergrads could follow it, or graduate students at least. So the basic overview is to create a cluster. You're on your HPC system. Instead of QSub or CSub or MSub or whichever you use HOD create. After you've loaded the HOD module, if you're using a module system, you can then, once it's been created or it goes through the queue and then it spawns, you can connect to it like any Hadoop cluster, and then from there you can use Yarn, Jar, job submission system. If you have a very long queue and you don't want to wait around for the job to submit, you can do interactive analysis. You can do hot batch, which you can use a script and it just sets it and it runs like any normal QSub that you would do, except this time you're using Hadoop. Of course, if you have a bunch of Hadoop clusters running at the same time, you would use HOD list. There's quite a few more commands, but these are the ones you probably use every day if you're using it. So the command line is pretty simple. You want a cluster of 4 nodes, HOD create, give it a label so that you can find it in the future. You tell it which distribution of Hadoop you'd like to use. For instance, here we've got Cloudera. Once it's running, you just connect, give the label name that you're going to connect to. If you use Vagrant, like Nicholas was talking about Vagrant, if you use that, it's extremely similar to just connect. And then once you're running, you can just run your Hadoop jobs. For instance, here's a basic word count. If you wanted to do the batch, so for instance, if you wanted to do 16 nodes, you just run with N16 here, and that's give it a script, and it's almost the same thing, and it's running on many machines. And you can align the arguments with environment variables using HOD batch list. You can always use the same Hadoop distribution. We also support IPython Notebook. We had a successful classroom activity with some graduate students who were using IPython Notebook to do their analysis. Using systems that had 64 gigabyte memory per node, so to do their machine learning analysis, they were able to do this on our system instead of having to use a laptop or use Amazon or some other cloud system where they have to pay because they don't really want to have the funding for their graduate students to work that way. So to get to the point of why we built this, why not just build a big data system? And by big data system here, I mean a lot of people conflate Hadoop cluster or Hadoop stack with big data. Why not just build one of these, or why not just go to the cloud? And the difference here, the main difference here is, of course, that the traditional HPC system is going to be a whole bunch of worker nodes talking to a few nodes of a parallel file system. So you'd have, for instance, we use GPFS, but you could be using Lustre, Panasys, or I'm sure there's plenty of others. Whereas with HDFS, one of the main insights was that if once you scale to a certain point and you've got so many nodes, and you're going to start soaking your bandwidth to the storage nodes, then you're stuck, and you should have local storage, which is where HDFS comes in. Which, for very big systems, that's a really useful idea. However, where we fit in is within European HPC, we are covering tier 2 and tier 1. So the way European HPC works is you've got 3 or 4 tiers of HPC. So tier 3 you could think of as your desktop, your laptop, where you're running your scientific programs or codes, as people in the HPC community say. Then your university might have a cluster. This is what we would call tier 2. Within Flanders, we have a tier 1, which is like a national center for HPC. We have one in Ghent, but I think towards the end of the year, it's being deprecated in favor of one that is being built in Leuven now. And then at tier 0, you have a few machines at supercomputer centers around Europe. So there's 2 in France, yeah. Some in France, Italy, Spain, Germany. I don't think Belgium will get one, but maybe in the future they will. So here's an idea of the size of the clusters we run, whether or not we're going to ever get thousands of nodes, as you see in the Hadoop papers or the MapReduce papers where Google is running with thousands of nodes. We've, before I joined, someone had the bright idea of naming the clusters after Pokemon. So quite a few of them have been deprecated. We used to have Gengar, Ghastly, Haunter, but these are the ones that we have running now, the tier 2 ones. And probably, to me, the most important one for working with big data is FAMPI, which is chosen to be an elephant because it's suitable for crossing the gap. Notably, we use 512 gig per machine, and it's only 16 nodes. But with this amount of memory, actually a lot of problems with the I/O interaction go away, especially if you're using IPython with a Spark backend. We are very happy with the performance, basically, of what people have been using it for. Another one that we had got in last year was Golet, which is 64 gig per node, which is also really useful. And this year we're going to be installing Swalot, which is 128 gig per node. Not specifically for a high memory machine, but it's a lot of memory and a lot more nodes than FAMPI, which is only the 16. We also have the tier 1, which is Mach, and the tier 2, the tier 1 in Leuven, which I don't think has well, they didn't choose a Pokemon name because they're not they're more serious than us. But yeah, this is going to be a really good machine for HPC. I'm not so sure it will be suitable for running 580 nodes with Hadoop, but that's not what we're trying to do. And just for comparison of the nodes, in case you forgot, Swallow only has 128, and the tier 1s have almost 600. So I think most people, well actually we have a lot of HPC people, so this might be a very useful slide. You might not be familiar with the Hadoop stack, but basically you have your HDFS as your file system, and on top of that you have Yarn running, and Yarn is a job scheduler that can talk to all sorts of different application containers, I guess is the name. We've taken off HDFS and replaced it with GPFS. And we keep Yarn as a scheduler, but it's also running on PBS, which is another job scheduler. And I spent a bit of time talking about the disk locality, because if we take out HDFS, will that run into problems? Well, if you're running more iterative jobs over and over again, like Spark, performance improvements coming in from Spark is because once you've loaded the data in, then you can keep it in memory. Having all the local memory is, having all the local disk is less and less important. And sure, it's the case that if you have an 8 or 16 gigabit per second connection to your parallel file system, you could soak that really easy with a lot of nodes if you have to get in a lot of data. However, in practice, in 2012, for instance, Cahera came out and said, here's a report on job sizes that we see. And sure, there's a lot of jobs that are extremely large and would not be a good use case for our system, but we probably get 80% of our jobs, well, maybe 90% of our jobs if we include FanPy. It's not really fair because FanPy is a very modern machine and this is in 2012 and technology moves that quickly, but these days FanPy could fit most jobs in a single node anyway. So we really feel that this is something, well, when we were working on HED, we really felt that this is an approach that can be successful. As long as we understand that there's limitations when we get really, really big. So that's why we built it, and it lets us run Hadoop clusters on HPC. So how does that work? You're going to be, as a user, you'd be on your laptop, you SSH into a login node, and from there you submit a job to the cluster.
Is it generally?
Oh, I'm sorry. Is it when I turn around or just?
Just in general.
I'm sorry. I actually feel like I'm yelling, so. Sure. So the way HED works is it's essentially a cluster within a cluster. So it will start the Yarn cluster, the purple box, within the actual PBS cluster, PBS being the job scheduler, or job controller, whichever you call it. And it just will take the nodes, turn it into a cluster. Once you've done that, you can access web services by making an SSH tunnel, and then you can set up your proxy, and then you can have access to all the web things. This is how we do the IPython notebook, for instance, and this is how if you do any of the web front-end system to monitor your Hadoop cluster, this is how you could do it. For instance, Impari is another thing that I haven't implemented yet on HED, but I think that would be a very useful way for people to monitor their HED clusters. So you might remember that when I ran HED create, I gave it a dist. And so you might say, well, what's a dist? A dist is a directory which contains a HED.conf, which is like a manifest. And within there, there's a few other scripts, which are configurations. And so here is one for IPython notebook, and we have the HED conf, which is the manifest, and then we have these other jobs, which will be started, and then we have just a utility script for the IPython notebook itself. The HED conf lets you define some modules. So in this case, we're using, is the purple or the pink on black hard to see? No, it's okay. So for instance, here we have IPython 323. This uses native I/O stuff with Intel, and it connects with Python 2710. Users can clone this and just add in whatever they like, and if I'm not fast enough in getting IPython 4.1 out, which is available, but I haven't provided a distribution yet, but users could just take this, replace the modules, If it's installed on a system, they could also install it on our system using Easy Build, for instance, is a project for installing software for users. You can do that, and you're basically good to go. The nodemanager.com, for instance, so this is one of the services that comes up. It was inspired by systemd type configurations, but it's not the same. I wasn't dogmatic about it. So for instance, here we do it uses Easy Build, so ed root Hadoop, and then it goes to the script and just starts the node manager. Pretty simple. You can also configure the environment as it runs, and you can tell it if it's going to run on every node or just the master node or the various other nodes, and it gives it a name. Pretty straightforward, I hope. I think users can understand this as well, so if you're administrating a system, you could say, well, you can update it yourself if you really need to. Well, what you might have noticed, especially when you think about Nicholas's talk, I didn't see where he went, but there he is. I haven't put in any of the Hadoop configuration things, so but obviously the defaults are terrible. Well, I have auto-generated content. So this is links really well into Nicholas's talk. If you guys were here earlier. I went through all the blog posts, I did some profiling. I really need to look at a load job and take a look at this. I automatically generated configs now. It was a bit trepidatious to put this feature in because it's an unbounded problem, and I will never get everything correct for every job. That's not possible. So if you want, in the HTTP conf, all you have to do, instead of using XML, because I refuse to put XML in, well, at first I put in XML, but then a colleague convinced me to refuse. Well, you just do yarn, blah, 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 and you can give it some config overloads, and these will overload. It doesn't use, there's nothing complicated, it would just do a straight replacement. So if you have like one memory overloaded, you really need to start getting out your spreadsheet and configure all the other memory systems as well. And I'm going to speed up. But it understands the yarn site XML, it understands Spark defaults, so if you give it Spark defaults, instead of using XML, it will use the space delimited, which is the detail, and it also understands log4j format. You need to control the logging. So user stories, we've got a guy in Ghent named Dries de Cap. He uses anything on demands to profile. He profiles also on an Intel cluster and also on Amazon Web Services. He's also funded by Intel. In his paper, he put in the results for the Intel Big Data cluster that's in Britain, where it ran pretty reasonably well. It's comparable to Amazon. He also ran it on our system, and he did a parameter sweep, and the fastest one, of course, we made a cherry pick, ran in half the time. That's 5,000 seconds, which is it's about half the time. This is also not fair because this is 64 gigabyte of memory per node, and this is FanPy, which has 512 gigabyte per node. So it's completely not fair, but it's not I/O bound, and it's not losing because it's not using HDFS, which I think is the important point. So that's a good thing. We also had in the soup is Professor Dirk van de Poel, and he had a graduate school class using this, 64 users, huddled around 5 per desk, because we couldn't spare so many nodes for the reservation, and they were able to do their graduate school project for his big data analysis course, and in the end it was pretty successful. I've only got a few minutes left, so I'll quickly go through the code, some limitations, because I'll try to be honest, and community. So it's Python 2.7, DLV2. I have about 80% code coverage, which I think is pretty good since it's a really new project trying to stick HPC stuff and Hadoop stuff, and we have Jenkins builds that make sure that it keeps getting tested on each PR. Limitations, it's only PBS. So anyone here using Slurm or Sun Grid Engine or Univa Grid Engine, unfortunately it's not supported at the moment. That's something I'm interested in having, but I can't really reuse PBS exclusively, so we can't really I can't really implement it for you because it's not really useful for our time unless we can come to an arrangement. But I'm happy to work with people to make sure that can happen because that would really get penetration into more HPC people sites, and then we could have it used more and more and more. The other limitation is that some of the job control is using Python 2 and it's not using Twisted. So dealing with the asynchronous jobs coming up and down is based on sleeps, and it's something that could be better if it was. Am I closer to mouth? No. Oh, sorry. Good. Time's up. So, in the end, would you like it at your site? Is there anything you need? You want to start with grid engine and some stuff we can talk about. And so, just to let you remember what I've told you, because you told people what you're going to tell them, and tell them again. HAD lets you run HPC, Hadoop on HPC, auto-generated configs, being used for actual research. And HPC can make pretty good big data clusters for certain definitions of big data. And yeah, please check it out. And there's questions.
Do I understand correctly that you throw away the HDFS and replace it with GPFS?
Yes.
Okay, so you have no problem with InfiniBand anymore?
Well, this is an interesting topic. So as Nicholas mentioned, Ohio State has a version of Hadoop that uses RDMA for the fetcher. Seagate released an open source version of Hadoop that takes the fetcher and just uses symlinks, well not symlinks, hard links in the file system anyway. So the fetcher doesn't have to do anything, which is nice, but they're a bit touchy. And IBM also has something for GPFS. Which is an adapter, and I've tested this, but it's also very flaky. So I want, and it's available as a distribution in HAD, but it looks like I've not answered the correct question.
My question is a little bit different. Normally you need a single interface, IP interface, if you're running an HDFS client. You have only one contact port. And if you're running InfiniBand, you normally have two interfaces. Ethernet and InfiniBand, but you have only one fully qualified domain name that to bind to. So how do you solve this problem?
Yes, so in the configurations, let's see if I can find it again. So for, does this one have it? Well, okay, so there's little environment variables you can use, like $local work there. So this is a local working directory for the node. There's also host name and host data name. And the host data name is the ID interface, and the host name is the other interface, which would be the FQDN.
So you were running Hadoop security.
Well, this is another limitation, I guess. I should have put our security model in our HPC system is based on you can only SSH to a client, a node, if you're running a job on that node. And I hope I've done it correctly, but we configured it so it only looks at the local host when, so there's a mask for the server to say only look at the local host or any port.
You can check the username.
Sorry?
You can check the username. And then you are anyone.
You can
It's only if you are supplying Hadoop, you are secure. And then you have a problem with the principles. If you're running two different outputs, etc.
Okay, well, I was under the impression that we had the IP mask set up so that it would only accept connections from the local host. So you need to be SSH tunneled into the machine and using that proxy in order to access the web services.
But you don't run identity. If you're using localhost, then
Yes.
that's not protected.
This is something I want to get working correctly. It's been on the table for us, and we've been thinking about how to do it correctly. So I'm happy to download your brain and find out more.
Any more questions?
you be interested in extending this to run on cloud?
Yes and no. I think that there's a lot of systems that provision for clouds, so I'm not sure that that would be terribly useful to people because that exists. And there's running Hadoop on HPC exists. There's my Hadoop and run Lockwood who's in San Diego, he's in Nurse now, so he's basically end of life it because he's no longer supporting classroom activities using it. But, yeah, I'm not. I think it's a good idea, but if there's PRs coming in, that would be useful. But I think that if it exists, probably then rewriting it would be a fun project. But I don't think we've had too many users because it's pretty well supported as far as I'm aware.
Okay, and with that we're out of time. Thank you again.